Good evening all, this is Indra from Pantech E-Learning. Am I audible? Good evening everyone. Joy C. Joy, good evening. Sri Devi, good evening. Hari Prasad, good evening. Ananta Shrikar, good evening. Sakshi, good evening. Hari Chandan, good evening. Vijay Lakshmi, good evening. Yeah, good evening all. Am I audible everyone? Are you guys able to hear me? Yeah, good evening. Batmavati, Tappas, good evening. Yeah. Thank you all for your response. So, this is our 5th day on IoT internship, and today we are going to see sensor interface and another topic like smart street light. Shall we start the session? Are you all guys are ready? Shall we? Yeah, thank you, Sailaja. Okay. So now let's move to the session. Today we are going to see sensor interface. So there is digital and analog sensors. We are going to interface analog and digital sensors. For that, first we have to know what is analog sensor and what is digital sensor. Can you draw up a single line answer like what is analog sensor and what is digital sensor? I just want to know your understanding about these digital and analog sensor. Can you please draw a single line answer for this? What is analog and digital sensor? And also if you know any analog sensor and digital sensor, you can also drop that sensor name. Analog sensor, any one analog sensor and any one digital sensor. Along with what is analog sensor and any one analog sensor and what is digital sensor and any example of digital sensor. Can you please drop the answers in the chat box please? I'm talking about the yesterday's remaining part. Yesterday we have already had already completed that ADC pulse width modulation and deep sleep, right? And we have also we're supposed to learn smart street light. So today we are going to see smart street light. Okay. Which read only digital digits or digital. Okay. Analog capture continuous variation, whereas digital or stepped or discrete. Okay. Digital gives output in digital form. Okay. Ananta Shrikar. Okay. Output is digital sensor. DHT11 is the example. Okay. Humidity sensor is the example of digital signal. Okay. Hall effect sensor analog. Okay. LDR analog sensor. Yeah. Okay. Okay. So thank you all for your response. Okay. So now let me explain it. Okay. So see, the digital sensors and these are the analog sensor, and analog sensor measures a continuous physical quantity such as like temperature or like pressure and produces an output signal that is proportional to the input. So the output signal is typically a voltage or like current that varies continuously with the input. Example of like analog sensor like thermocouples, pressure sensors, and you can take light dependent resistor, LM35, jockey, everything. Sorry, joystick. And coming to digital sensor. So, a digital sensor produces an output signal that is in the form of discrete values or like digits, only zeros and ones, usually in binary code. So, digital sensors typically use an analog to digital converter for what? To convert the analog input signal into a digital output signal. For example of digital sensors like optical encoder, like proximity sensors and temperature sensors. Here you can see like ultrasonic sensor, DHT11 and some more. So the choice between analog and digital sensor depends on the application requirement. So analog sensor are often preferred for like applications where precise measurement of a continuous physical quantity is required, such as in temperature or in pressure sensing, like that. So digital sensors are often preferred for applications where discrete or binary data is required, such as in like position sensing or motion detection, like that. So this is what digital versus analog sensors. So now this is the right time to switch your masterclass into internship. So these are the benefits you will get in this entire internship. What are they? 30 days of live sessions and 90 days of access to records and 8 plus source code of IoT projects, 30 downloadable presentations, and after registration you will get your internship confirmation letter, and after finishing 30 days masterclass you will get your internship certificate. So this is your discount amount, which is only for 799. Use this registration link to register and get your internship as soon as possible. So these are the add-on project which you will get in this entire internship, which are smart street light using LDR and IR sensor, monitoring soil moisturization using ASK sensor, gas leakage detection using Arduino IoT cloud, and IoT based heartbeat monitoring system, and BME 280 sensor readings to the real-time database, web-based remote serial monitor, and sending email using SMTP, and telegram request ESP8266 sensor readings. I am telling you this, the masterclass is only free. If you want the certificate, you have to pay for that. Okay. So now we can move to this topic, which is smart street light using IR and LDR sensor with ESP8266. So see, most of the places have automatic street light which can sense the daytime and as well as night time and automatically turns on and off according to the day and night. Here we are extending this by adding one more constraint to turn on the light. That is, street light will only glow if there is darkness and someone is passing through the street. So the main objective of this is to reduce the power consumption just by glowing the street light only when it is needed. So here we are demonstrating the prototype of the smart street light with one IR sensor, one LDR sensor and two LED. One is for LDR sensor, another one is for IR sensor. So now let's talk about the sensors first. First one is IR sensor. Have you heard about this IR sensor or have you worked with this particular IR sensor somewhere else? Have you? Or do you know what is IR sensor? What is the working principle of IR sensor? Can you drop the answers in the chat box, please? Have you ever heard about IR sensor or LDR sensor? So what is the full form of IR and LDR? Okay, thank you for a response. IR is nothing but infrared sensor. So it is an electronic device which is used to detect objects just by sensing infrared radiations. See, which is reflected from the object. Here in this picture you can see that. It mainly consists of a transmitter IR LED and a receiver photodiode. This is the receiver and this is the emitter. So it detects infrared radiation which have wavelength of like maybe 700 nanometer to 1 millimeter. So when a specific positive voltage is applied across that transmitter LED, it transmits the IR rays. If these rays falls on some object, that reflects back to the IR rays which are received by the receiver photodiode. So the receiver diode generates a voltage across its terminal which depend on the intensity of light reflected by that particular object. So generally IR receiver LED is like darker, which means I am talking about this black one, whereas the transmitter is transparent in color. This is the receiver and this is the emitter. You will get 3 pin. One is for output pin and one is for ground pin and another one is VCC. This is digital output pin. So this is what IR sensor is. Okay. So now let's see LDR. So LDR stands for light dependent resistor, also known as photoresistor. So LDR is sensitive to light and its resistance changes according to the intensity of light falling on it. It is made up of a high resistance semiconductor and its resistance increases in darkness and decreases in light. Again I am telling you this, note this. It is made up of a high resistance semiconductor. Its resistance increase in darkness and decrease in light. When light incident on the LDR, it exceeds some threshold. It absorbs the photons and allows electrons to jump into the conduction band. So, LDR generates a variable resistance which depends on the intensity of light falling on it. So, it is mainly used in electric circuits like street light, like alarm clock, automatic brightness and constant control like that. In LDR sensor, you can get both pin, analog and digital. Digital in the sense you can write code like high and low. If you use analog in the sense you can go for the variation. You already know. Analog is like 10-bit resolution. So you will get the value between 0 to 1024. If you are taking digital pin, there is only two numbers, zeros and ones. And there is VCC pin and ground pin. Both the sensor work at 3.3 voltage. So now, shall we move to the coding part? Let us write the code now. Okay. So first, I am going to initialize all the pin numbers. For that, I am going to take the data type which is integer. Let me give a name like, first I am going to give for LDR. Let's take D6. Now, LDR has its own LED. We are going to use one LDR, one IR and one LDR's LED and one IR's LED. During night time, that particular LED will be on. If any vehicle in the sense, that particular LED will also be high. So for that I am going to give name like integer LDR LED. This LED is LDR's LED. So here I am going to give like D3. Then integer IR, which is equal to, let's take D5. And now integer IR LED, which is equal to D2. So here we have mentioned all the pin. These are the 4 pins we are going to use in this topic. So now we can go for void setup. So inside, first what we have to do, we need to start with serial.begin. So inside we need to pass the baud rate, which is 9600, and then we need to set the mode using what function? Using pin mode function. I am going to set the mode. First is LDR. We can go with this LDR. So here I am going to give LDR, which is what? Input, because we are going to get the data from this pin. So this is input. And coming to LDR LED. Here we are not going to collect any data from it. So we can give like output. Now using pin mode function IR, we are going to collect data from this. So input. Now IR LED, which is output. That's it. LDR LED, IR and IR LED. So now we can move for void loop. So inside void loop, first what we have to do? Here I am going to read data from sensor and I am going to store it in a variable as usual. So first, which is integer, let us give a name like LDR value. Here I am going to read LDR data using what? Digital read function. Using digital read function, I am going to read LDR pin. And I am going to store it in a variable called LDR value. The same things for IR also. So integer IR value, which is equal to, using digital read function, I am going to read IR. So now I am going to make a if condition. So the first condition is for night time. We are going to check whether it is day or night. So the first condition is for night time. I am going to check this. So let me, if LDR value, which is equal to, double equal to 1. 1 means high, 0 means low. So I am going to check whether it is 1 or 0. If this is 1 in the sense, which means this is night time. So inside, what I am going to do, if this LDR gets high, which means if it is night time or not, right? So inside, if it is night time, I am going to make my LDR LED high. For that I am going to use digital write. Inside I am going to give LDR LED high. During night time our LED is supposed to be high. So after this I am going to check another thing. What? If any vehicle is detected or not. For that I am going to use another if condition, which is IR value, which is equal to 0. 0 means low. Low means digital write. So inside I am going to make IR LED high. I am going to print a statement like serial print ln inside. Let's write this command also. Here this is like detected. Vehicle detected or not. This is night time and this is supposed to be detected. So I am going to print a message like it's night time and vehicle detected. This is what I am going to print. And then I am going to give a delay. Let's give 2 seconds. Okay. So, see, if IR value is low in the sense here, which means vehicle is detected, then LED has to be high and then it has to print a message time and vehicle detected. And I am ending this with a delay of 2 seconds. So now the next condition is for if same night time. This time we are going to check for no vehicle detection. So it's the same thing. If LDR value which is equal to high, inside we need to make digital write of LDR LED high. Now I am going to check no detection for any vehicle. For that, if IR value, if it is high in the sense, inside I am going to give like digital write. I am going to make IR LED low. During no vehicle detection, there is no need to be, the LED has to be on, right? So now I am going to print a message like night time and no vehicle detection, like detector. Let me give a clarify for that. So night time and this is for no detection. Okay. So here we need to give a delay. Let's give 2 seconds. Okay. So now third condition. Third condition is for what? Daytime. Here we need to check whether the daytime is not. Using what? If inside LDR value, if it is low in the sense, which means this is daytime. Daytime. So during daytime, we need to off our LED. So LDR LED supposed to be low, and we need to check vehicle detection also. So I am going to give if inside I need to check IR value is low or high. If it is low in the sense, what we need to do? Digital write inside IR LED is also supposed to be high during detection time. So using serial printer, what we need to print? It's daytime and vehicle detector. This is what we need to print, and we can give a delay of 2000. So this is daytime and this is for detection. Okay. Now fourth condition. Fourth condition is for daytime and no vehicle detection. So for that we need to give like if LDR value which is equal to 0, which means low. So this is for daytime. Inside during daytime we can make our LED low. So using digital write, LDR LED supposed to be low. And now if IR value high, in the sense inside we can give for digital write IR LED, which is supposed to be low. During what? No detection. So after this, what we need to do? We need to print the statement. So serial println, this is for daytime and no vehicle detection, right? So we need to give like it's daytime and no vehicle detected. That's it. So there is actually 4 conditions. One is for C. First condition is for night time and vehicle detected. Second condition is for night time and no vehicle detected. This is for daytime and vehicle detected, and this is for daytime and no vehicle detected. We just need to mention the pin numbers, we just need to mention its mode, and we just need to write the condition. That's it. Just a simple program. So now we can go for the hardware part. We can make the connections now. So, okay. Now see this. Here I am going to place 2 LEDs. So see, this I am taking the first LED. I am going to place it here. And the second LED, I am going to place it here. On the positive side, we need to place a resistor, and here also. Okay. So see, here I am taking 2 sensors. This one is LDR sensor. This is for IR sensor. So this is IR sensor, this is IR's LED, and this is LDR sensor, and this is LDR's LED. So first let's connect the LEDs first. So let me ground this. Okay. So LDR's LED pin number is what? LDR LED, which is D3. Here you can see. So I'm going to connect this with D3 pin number, and then let me ground this. And IR's LED pin number is D5 or not, D2. Okay. So now we can go for sensor. So see, there is 4 pins. Here I am taking digital output, not analog. So first we need to give the first pin, D0. Digital pin supposed to be connected with what? This is LDR. LDR pin number is D6. So I am going to connect this with D6, and the next pin is ground. And then VCC. We can go for 3 volt. So see, let me connect my port to the power. After giving the power, you can see the LED will be turned on. See this. we give the power. And now I'm going to take this. First pin is output pin. So IR sensor pin number is D5. Here. So the center pin is for ground, like this, and this is the power pin, VCC. Here you can see. So if I place my hand here in the sensor, this means now only one LED is blinking, which means the sensor is powered on. During no vehicle detection, it will be like this. If I place my hand nearby the sensor, see, this means something is detected. We can take like this as vehicle detected, no vehicle detected. Detected, no detection. This is how it works. Same thing for LDR also. Actually supposed to blink only one light. I think there is. We change the pin to some other pin. LDR. Let's take D8. Okay, see, this means daytime. That's why two LEDs are blinking. If I place my finger like this in the sense, this means this is night time. There is no light is falling on this LDR. See, night time, sorry, daytime, night time, day, night. So the board and port is connected. Let me upload this. Thing. Just a minute. Let me place it at somewhere else. Okay. Let me select the port again. Component A. I think network is clear now. Are you able to see the video? Just a minute. Let me open it again. Like the port component 8, it's connected. Let me upload it again. Wait for a few seconds. There is some issue with me. I'm just showing you that how this sensor is actually work. I didn't upload my code into the board and I didn't show you the output. Okay, so Hemant Kumar, please wait for a few seconds. I will show you how the LED will be on and off. Just a minute. Some issue with my board, I think. I changed it to all the things, but I still don't know. Just a minute. Just wait for a few seconds. I will try it with another port. Let's check does it work or not. Javik, I already tried with all the port and I pressed reset button multiple times. I don't know what the issue. There is nothing wrong with my port. I think there is something issues with my board actually. I pressed reset button so many times. I still don't know. Maybe my board has some issue. I tried flash button too. Yes, I tried with reset button, flash button, everything. I changed the port also. Let me check if there is any output video. Maybe I'll show you that. Yeah. Thank you. Just a minute. See this? Are you able to see this, guys? Yeah. See this? Yeah. So see, here I place the two sensors. Let me open the serial port again. Now see the output. It prints like it's let me. Now it's supposed to print like it's night time and no vehicle is detected. See, I place my finger like this. During night time our LED is supposed to be on. So here during night time LED is on. if I place my finger like this, during night time, vehicle is detected. So both LED is in on state. This is night time. So during night time, LED has to be on, and during vehicle detection, the particular LED has to be on. Now, it's supposed to print like this is daytime, no vehicle detected. Sorry. This is daytime, vehicle detected. How it actually works. Now both LEDs in off state. It's daytime and no vehicle detected. It's daytime, vehicle detected. It's nighttime, vehicle detected. And it's nighttime, no vehicle detected. I hardly press a flash button and reset button multiple times, and finally it works. And I also left one port and I tried with that particular port. Now the output came. Maybe there is some issues with my port, I think, or I don't know. Sometimes what good, and sometimes it makes some issues like this. If you face any issues like this, in the sense, you can just disconnect all the things and connect it from the scratch, and try with all the port you have. Disconnect all and refresh the page, and you can use some other file. Close the IDE and reopen it again, like you can try it out. Is it clear? Maybe there is some issues with my port or pin, anything. I left one more port. I tried with that port and I repeatedly pressed that flash button and reset button again and again, and finally it worked. Is it clear, everyone? Hemant Kumar, Jaivik, is it clear? Thank you for a response. So if you face the issues like this, in the sense, just disconnect all the things and connect it again, or you can close the IDE and reopen it again and upload it, or try to upload it again also. Check with your port first. Connections, yeah. During daytime, if vehicle detected, we don't need light, ma'am. Yes, during daytime, your daytime LED will be in off state. If vehicle is detected, in the sense, it's supposed to be high, right? So see, this is night time. What happened? Also check your connections too. If there is any loose connection, it doesn't blink. See, now it's night time. Night time, your LED has to be on. Now this is daytime. LED is off. This is for no vehicle detection, and this is vehicle detection. If vehicle is detected, in the sense, it has to be high. If no vehicle is detected, in the sense, it has to be low. If it's daytime, in the sense, there is no need to be, your LED has to be on. During night time, it has to be on. During night time and during vehicle detection, both should be in on state. Is it clear? Is it clear, Selva Kumar? So this is the output. Okay, again I'm telling you, these are the benefits you will get in this internship. 30 days of live sessions, 90 days of access to records, 8 plus source code of IoT projects, and all downloadable presentations and notes. After registration, you will get your internship confirmation letter, and after finishing 30 days masterclass, you will get your internship certificate. And you have to pay just $799. Use this registration link to register for this internship. And these are the ads-on project you will get in this entire internship. Sorry. This is all about today's session. This value is just 1K Om Hari Prasad. The color code is BBR. Brown, black, red. So that's it. Thank you all. Have a very nice day. Let's catch up at tomorrow's session with different topic. Thank you all. Yes, Arduino also the same code, but instead of giving D like that, in the sense you are supposed to give, you have to change that pin number. Arduino has a different pin number and you have to mention like in different way, but the code and concept everything is same. Yeah, thank you all.